Hello students, welcome back. We completed section 1, now let's go to section 2. But for the students who skipped section 1, let's have a brief summary. We talked about continuous random variable, and it consists of continuous CDF, and the probability density function, PDF like this. And we have these features. Number 1, non-negative. As you can see, both graphs are above the x-axis. Number 2, toward positive infinity and also toward negative infinity, going down to 0. Yes, to the right-hand side, to the left-hand side, both going down to 0. Number 3, the probability corresponds to the area, as you can see from this shaded region. Area underneath the curve, above the x-axis, between A and B, either this way or that way. And by the way, this curve in the left-hand side, that's the normal random variable. Apparently, it's simpler than something like this. And yeah, that's one of the reasons that we study normal more than anything else. It's simpler, it's easier. Okay, let's go to section 2, normal probability distribution. What is a normal random variable? It's a continuous random variable associated to the probability density function, like this. But don't pay too much attention to this algebraic expression because we are not going to be using any calculus here. Instead, focus upon the graph. And remember all the features of the graph. First, symmetric, unimodal, and horizontal asymptote y equals to 0 and those kind of things. Also, please remember this. Mean, median, and mode, they're all the same here. This mu is for mean, but it doubles as median and mode as well, as far as the normal is concerned. If you go to something else, such as this one right here, then there are two modes. Here's a big mode, and then here's a smaller one. So it's not unimodal. And mean is going to be somewhere around here, a little bit more to the right. And then median is going to be a little bit, it's different. Mean, median, mode, they're all different in general. But for normal, they're all the same, and we have symmetry. In short, it's simple, much simpler than other cases. Alright, so much for the properties regarding the mean, mu. Another quantity is standard deviation. You see, in this algebraic expression, we have this mean. Also, we have sigma value showing up there. That's the standard deviation. And what is the role of sigma? Well, what did you study in week 1 and week 2? The bigger the standard deviation, the more spread. And the smaller the standard deviation, the less spread and concentration toward the mean. I think I better show you that through some manipulation like this. Okay, here's an interactive normal picture, and let me increase the standard deviation, getting bigger and bigger and bigger. Sigma value, what do I see? Getting flatter, getting more spread. Visualize a pancake dough pressing from the center, and then what happens? The dough is spread out, pushed out. We get more spread, and that's basically what we're looking at. Becomes flatter. Now let's go backward. Smaller standard deviation, and we have less spread, and consequently more concentration toward the center. Center, I mean by the mean, median, and mode, they're all the same, so I'm going to call it center. What if I change that center? Change the mu value, then what happens? The entire normal graph follows it. Because that's mean, median, mode, the same thing. Alright. we went through most of the important graphical features of normal random variable. Now, let's consider a motivation. Why do we study normal? Well, one reason we already discussed, it's simpler. You see, go back there and then compare. Look at this normal and something weird. Normal is simpler, something we can actually do and understand. That's one reason. Okay, yeah, that's good enough, but there's even much bigger reason. Here's a motivational example. Please stop the playback and read through. So, what is your impression? This is highly realistic problem. Actually, not just realistic, it's a real problem. If you are a parent, then of course you'll understand the importance of this kind of problem. And of course, if you're working as a healthcare professional, then perhaps even more so. And we have all those data regarding, 6-month-old boys and then 21-month-old girls, all kind of things about development of children. And of course, there are many other examples too associated to normal. We are talking about something very, very useful in terms of real-life application. And all these problems are associated with the normal picture, like this. Like this. That's the second motivation. So motivation number 1, it's simple. Motivation number 2, it's useful. And there's a third motivation, which we will discuss in Module 9. Still, I think that's enough, especially the second. It's useful, especially in terms of real-life application. Now, how do we actually use it? We need one more theoretical step called the standardization. And don't be intimidated, okay? My purpose here is to introduce you with this formula. This is the formula number 1 for this entire course in terms of the level of importance. Theoretically, there's some subtlety here, but not too much. Basically, what it says is, if you have a random variable x, I take it back, if you have a normal random variable x, then of course it'll come as its mean and the standard deviation. Let's call those as mu and sigma. So mu is the expected value. Sigma is its standard deviation. All right? And then we can do some algebraic manipulation and create a new random variable z, like this, x minus mu over sigma. If you do that, then the new random variable is also a normal random variable, and it has mean 0 and standard deviation 1. Basically, what we did is we have some arbitrary normal random variable and do some algebraic manipulation and made it into something extremely simple. And that extremely simple normal random variable is called standard normal random variable, and people already did some computation about it, and we're going to discuss how to use the standard normal random variable in the next section. Alright, so much for section 2, and we're going to talk about the standard normal random variable in section 3.